So in this video, i-discuss ko naman kung ano yung mga values or expressions ng entropy at different PV processes. Okay? So una, we have this isothermal or expansion or compression where the temperature is constant or dT is equal to 0. So for ideal gases, okay? So take note natin that this is an ideal gas. Okay? So itong mga process na to ay for ideal gases only because of the equations that are given. So, yung work, for example, that is for nRT over V, di ba? For ideal gases yan. And we have expressions of du and dH, which is only a function of the temperature. So, that's also for ideal gases. So, take note that all the processes mentioned are for ideal gases only. Okay? So, for isothermal, going back, we have ds is equal to Cv dt over T plus nR dV over V. So, cancel itong value na to since that dt is equal to 0. So therefore, the ds for this process is nr dv over v. Okay? So this is also equal to nr ln v2 over v1. Okay? So the integral of this is nr ln v2 over v1. Ito naman, okay, ang integral nito ay negative nr ln p2 over v1 or p2 over p1 pala, sorry, which is also equal to positive nr ln p1 over p2. Okay? So, therefore, ito na yung summary. Delta S for isothermal processes is equal to nr ln v2 over v1, which is also equal to nr ln p1 over p2. So, kapag ka pressure, p1 over p2. Pag volume, v2 over v1. Okay? So, punta naman tayo sa mga isobaric processes. So, for isobaric processes, the pressure is kept constant. So, dP is equal to 0. ds is equal to Cv dt plus nr dV over V. So, makakancel yung dP over P kapag ka ds naman na in terms of temperature and pressure. Kasi this is temperature and volume. Okay? Walang makakancel dito. So, ito na yung value nun. So, for ds in terms of temperature and pressure, cancel yung negative nr dP over P. So, the integral of this is Cp ln T2 over T1. Okay? So, for this one, ang integral nito ay Cv ln T2 over T1 plus nr ln V2 over V1. Okay? So, is this equal to this? Tingnan natin. Okay? So, Charles' law, V1 over T1 is equal to V2 over T2 at constant pressure and number of moles. So, from this equation, okay, delta S is equal to Cv ln T2 over T1 plus nR ln T2 over T1 kasi ito yung rederivation ng Charles' law. Okay? So, V2 over V1 is equal to T2 over T1 according to this law. So, therefore, this is Cv plus nR ln T2 over T1 kasi pwede nating i-separate itong terms na to. So, therefore, this equation is just equal to Cp ln T2 over T1. Okay? So, therefore, equal lang to tsaka ito. So, you can just use Cp ln T2 over T1 sa delta S ng processes at constant pressure. Okay? Next is for isochoric process. So, the ds is equal to Cv dt over T, okay, plus nr dV over V. So, since dV for isochoric process is 0, okay, so the dV here is 0, so this term is cancelled. So, it's just equal to Cv dt over T. So, ang integral nito ay Cv ln T2 over T1. So, that's what happens when you integrate this. So, for ds in terms of pressure and temperature, ito yung S in terms of temperature and pressure, Cp dt over T minus nR dP over P. So, therefore, yung delta S in terms of temperature and pressure ay ito, okay, Cp ln T2 over T1 minus nR ln P2 over P1, while delta S in terms of the temperature and volume, pero constant in volume is just Cv ln T2 over T1. So, is this equal to this? So, we will use the Gay-Lussac's law to relate pressure and temperature at constant volume and number of moles. So, based on the Gay-Lussac's law, P2 over P1 is equal to T2 over T1. Therefore, okay, delta S is Cp ln T2 over T1 minus nR ln T2 minus T1. So, pwede natin i-separate to get this, Cp minus nR ln T2 over T1. So, based dun sa Cp is equal to Cv plus nR. Okay, makukuha natin na ito ay equal lang sa Cv. Okay, which is this. So, Cp minus nR is equal to Cv. So, the delta S, even at as a function of temperature and pressure, is equal to Cv ln T2 over T1. So, in summary, okay, kapag ka dP is equal to 0, okay, delta S is equal to Cp ln T2 over T1. kapag dV equals 0, delta S is equal to CV ln T2 over T1. Okay? So, ano pa? Kapag dt is equal to 0, therefore, delta S is equal to NR ln V2 over V1 or NR ln P1 over P2. Okay? So, that is for the delta S of various PV process. So, what if ang process nyo ay reversible adiabatic? So, kapag reversible adiabatic process, kapag 0 ang iyong dq rev, okay, 0 na rin ang iyong entropy. Pero kapag yung process mo ay irreversible, okay, you need to imagine the reversible counterpart for that process. So, aaralin natin to pagka nag-proceed tayo sa thermochemistry. So, i-determine natin yung delta H, delta U, tsaka delta S ng bawat isang process na nag-occur naturally sa ating environment. Okay, magbibigay ako ng mga examples, tapos magde-determine tayo using this particular technique. Okay? So, this is how you do this. So if you divide divide the irreversible step into a series of reversible steps, the delta S, so the total delta S for this irreversible step will just be the sum of the individual reversible steps. Okay? So later na natin ito gagawin after ng mga PV processes kasi sometimes may mga non-PV processes like phase changes, etc. na may ibang equations for delta S. Okay? So, recall natin yung sample problem na sinolve natin nung nakaraang video. So, in this problem, 1 mole of monoatomic ideal gas was expanded isothermally and reversibly from 0.5 to 2.5 liters at 298.15 Kelvin. So, this is the first step. Okay? Then, the gas was compressed adiabatically and reversibly to 1 liter. This is the second step. Then, finally, the gas was compressed isobarically to 0.5 liters. So, this is the final step or the third step. So, take note that this is a monoatomic ideal gas. So, the CV for this gas is 3/2 NR, while the CP of this gas is 5/2 NR. Okay? So, all we need to do is to calculate the entropy of each step. So, first, we calculate the pressure, temperature, and volume per step given that the number of moles is 1 mole. Okay? So, sa unang step, given natin yung V1, which is 0.5 liters, T1, 298.15 Kelvin. Okay? So, lagyan natin ng unit. So, all that is in orange, itong pressure 1, pressure 2, pressure 3, tsaka T4, and temperature 4, were calculated using the ideal gas equation. Okay? So, P1 is 48.930 atm, P2 is 9.786 atm, P3 is 45.065 atm, and T4 is 274.599 Kelvin. So, T3, however, was calculated using the adiabatic relation. So, from state 2 to state 3, so that is step 2, V2 is given, V3, the final volume is given, T2, which is 298.15 Kelvin, is given, CV of the gas is given, siya yung 3/2 NR, NR is of course given kasi meron tayong 1 mole and the gas constant is 8.314. However, makakancel lang naman yan dito kapag sa sinubstitute nyo na yung CV. So, you can easily calculate for T3. So, T3 is 549.197 Kelvin. So, the next thing to do is to calculate the delta S for each step. So, given na tayo ng mga parameters, pressure, volume, temperature, makakalculate na natin yung delta S for each step. So, for the first step, this is an isothermal expansion. Therefore, the change in temperature is 0. So, delta S is NR ln V2 over V1. So, this was derived since delta U is 0. Therefore, Q or dQ is equal to negative dW. Okay? Therefore, dQ or the integral of dQ reversible over T is NR ln V2 over V1, which is this one. Okay? So, substituting the values, 1 mole, that's N. R is 8.314, ln V2 over V1, 2.5 liters over 0.5 liters. That is delta S is equal to 13.38 joules per Kelvin. So, for the next step, since this is a reversible adiabatic compression, the dQ reversible is 0. Therefore, the delta S is 0 for each or this step. Okay, so finally, for the isobaric compression, the pressure is 0, okay, or the change in the pressure is 0. So the delta S for this step is Cp times ln of T4 over T3. So substituting the values, this is 5/2 NR, okay? So 5/2 times 1 mole times 8.314 times the ln of the final temperature, which is 274.599 over the initial, which is 549.197. So the value of delta S is negative 14.407 joules per Kelvin. Okay? So this is the sample problem, or this is how you calculate delta S for each PV process. Okay? So see you next video.